Next up, we do have another talk all about, well, you get the idea by now, tackling enterprise code modernization with AI. This is actually a session sponsored by Tab9, who'll be doing a little breakout later if you want to know more about what Tab9 does. The presentation is going to be run by John Feeney, who is a principal architect within the CTO office at Tab9. Prior to helping Tab9's customers accelerate their software development cycles through the use of AI, he worked with various APM and DevOps tooling vendors to help drive development and operational efficiencies. He's based in Dublin, Ireland. John, over to you.
Hi, everybody. John from Tab9. So, in this, I want to talk about Gen AI for code modernization and for application modernization. Just want to share with you some of the things that we've seen, working with some organizations who've embarked on this journey. So let me try and move on here. Okay, I'm going to kick things off with a definition, right? So what do I mean by application modernization? So, we're talking about taking an old system and upgrading it to modern standards and requirements to deliver business value. So, as business operations evolve over time, the systems that power those operations, they need to evolve too, but that doesn't always happen, right? And so we're looking to bring these applications up to speed to meet the current and the future needs of the business. So by doing so, we'll not only be introducing modern software capabilities, but also modern security measures and making it available to modern architectures as well. And, this is something that's a very hot topic at the moment among many IT operations. Now, the challenge that we're faced with is that many of these systems, they've been powering businesses for so long, right? 20 years, 30 years, maybe in some cases, 40 years or more. And, they've proven to be resilient and reliable and, they just work. Now, there's an obvious inclination then to, maybe put any modernization project on the back burner, right? There's, been hundreds, thousands, and in some cases, maybe even millions of hours that have gone into these systems, and it's just way too scary to consider revamping them. It's hard to justify the business case, right? Sometimes as well, it can just be too costly, right? There's no clear benefit or return on the type of investment that's going to be needed here. Or maybe, there's a short supply of the necessary skills and expertise to, understand the inner workings of these systems and bring them up to speed. So lots of reasons as to why a modernization project might not happen. But personally, I think these last 2 points here are very strong imperatives, actually, for a modernization exercise. Sometimes the cost of modernizing a legacy system can be far less than the cost of, sticking with a vendor of a very outdated system. And also, if you're facing a situation where there's a shortage of skilled or specialized labor to maintain these systems, that's introducing a lot of risk and exposure to your business. And, you're also hampering your ability to innovate. So, reasons there to modernize a legacy system. And the good news is that there's never been a better time than there is now. Gen AI, it's really providing wonderful and new opportunities and really revolutionizing what's possible in terms of application modernization. It's greatly reducing the time it takes to do this type of thing, from a matter of months down to mere weeks. Now, before I go any further, I just want to do a quick level set. If some of you are coming into this thinking that, hey, maybe AI is kind of at a point now where, I can just press a magic button and it'll do all the magic for me, all of the modernization, all the heavy lifting, and I don't have to do a thing. Well, unfortunately, that's not the case. There is no magic button. It doesn't work like that, and it's never going to be as simple as just, a line-by-line conversion. Whether you're working on a monolithic application of some sort or working on a cross-domain system, any modernization effort is going to require the involvement of human stakeholders. There's no really way around that. Now, so what you have to do instead is you have to take a really holistic view of things and really consider the context within which this modernization exercise is occurring. So, are there any data optimization opportunities here? What is the new data structure going to look like? What should it look like? What about the compute side of things? What is the target architecture of this system going to be? Are we going to build this for cloud native? Is it going to run in a container? What about the functional requirements for the system? Have they changed? Or, the non-functional requirements, do we need to take into account any performance considerations or observability constraints? Also, like DevOps, do we want to introduce DevOps practices to this system? And if so, what are the changes that we're going to have to make to facilitate that? So, the context in which you're doing all of this is really, really important. And also, as with all aspects of software development, you really do want to avoid a big bang approach, and you want to take more of an agile approach to this exercise. Technically, if you throw a large body of work at Gen AI, very often, you're going to get a less than satisfactory result, or the fidelity of the output is going to be less, right? And you might also run into limitations like token limits and context window size limits and things like that. So really, it's much better to take, to break the work down into much smaller constituent pieces of work, right, that are easily managed, easily digested, and easily understood. And, it's going to be like an MVP approach to this work. And, in true agile fashion, you want to kind of iterate constantly and eventually towards your end solution. Now, in addition to all of this, what's really crucial with the modernization effort is subject matter expertise and knowledge. And so there's really no substitute for that either. If you were to take the most brilliant engineer off the street, point them at a legacy system and say, modernize that, they are going to struggle massively in the absence of any domain knowledge. And that is true as well of AI. So you do need to provide that knowledge in order for the modernization effort to be successful. And I'll talk about some of the approaches that some organizations are taking to do that. Anyway, all of this is to say that application modernization is very much a human-assisted affair. Your before me spoke about human in the loop, and that is very true here as well. Depending on the complexity and the heterogeneity of the system, you're going to need various people involved: SMEs, designers, people to review the code, architects, and so on. Okay, with all of that out of the way, massive disclaimer. Let's move on to some of the topics that I'd like to cover. So I want to talk about how Gen AI is going to greatly assist with reverse engineering a legacy system, generating the new code, ensuring that generated code is in line with best practices for your organization, how you can ensure that code works through tests, and have AI help you greatly with that as well. And I'm going to talk about reducing technical debt and also documentation for the new system. Now, I'm probably going to run out of time here, and in fact, I know I will, but there is that breakout session afterwards. So if I don't show anything here, we can cover it in the breakout session, where I'd love to see you if you can make it. Okay, so let's kick things off with reverse engineering. So, as I mentioned, some of these enterprise systems are very old, decades old in some cases. And, we're talking mainframes, legacy CRMs, niche systems. And some of the challenges that businesses face is that the original developers of those systems have moved on. The systems are either poorly documented or just not documented at all. There's probably a lot of duplication of functionality in there and inefficiencies in the code. And then worst of all, we probably don't even have access to the source code anymore, right? So somebody coming into this situation, there's a lot of mental effort required and a lot of time that's required to parse a legacy system like this, especially one where the code and the data models have really evolved over time to become quite complex. And, to build a mental model of all of this functionality can be hard. Now, as humans, once we get past a few thousand lines of code, our brains, they don't scale very well. And that's where things start to kind of break down. But that's where Gen AI can really step in to save the day. And it's, as we all know, Gen AI is fantastic at explaining code. And so, LLMs, they're great with text, parsing text, summarizing text, and code at the end of the day, that's what it is just text, right? So first thing you're going to do, if you had an SME or a senior developer who's, very intimate with the system, you'd ask them, hey, listen, can you explain what this code is doing to me, right? Can you summarize the code? Tell me what the key aspects of this system are, and fundamentally what the business logic is. And that's where AI can really help. To give you an example, if you're faced with a huge monolithic application that's tightly coupled, and if you're looking at thousands of function calls, and within each of those functions there's calls to other functions in turn, that can be quite challenging. But you could turn to Gen AI and say, hey, listen, can you examine all of this and analyze this code and create a call hierarchy for me? You could also ask it to perform some sort of similarity scoring where you're looking to identify any overlap in the functionality, any duplication of the code. Maybe you want to kind of just maybe abstract out some of that code into reusable components, right? So AI is great at that kind of thing. And so you can break that monolith apart, and you can take what you've learned there to form the basis for a microservices architecture, right? And you can also use that understanding as well to generate the documentation for the new system, and also crucially to create the tests that we'll use later to test that the new functionality works as expected. All right. So I'll show a couple of examples of this a little bit later on the testing side of things. So that's reverse engineering. And again, this is not about converting line by line, but rather taking a very deliberate, methodical, and holistic approach to modernization. All right. So once we've understood the system, how do we then begin? How do we start kind of generating code? And so, as we all know, Gen AI really great at generating code, whether it's, if you want to parse some JSON or write a SQL query, or, just convert code from one language into another. Gen AI can deliver immense value out of the box. But the challenge that we face is that when we're creating software, we want to create solutions that are predictable, right? We want to create consistent solutions, things that are repeatable. And that's why, for example, infrastructure as code is so popular. The challenge with Gen AI, though, is you have to deal with non-determinism. So depending how you ask the question, or, due to some variation, a small variation in your prompt, you can get a very, very different outcome, or different, you can get very different code in response. And that can be challenging. Now, you'll get a solution of some sort, but it may not exactly be what you're looking for. In the worst case scenario, you're going to get something that just doesn't meet your functional requirements. And in the best case scenario, it's the solution you're looking for. But then the question becomes, how do we make that process repeatable, right? How do we introduce some kind of determinism? So I'm going to talk about an approach that many organizations take to do that, and that's RAG. So RAG, or retrieval augmented generation, is a means by which we take a pre-trained model, as you can see on the right-hand side of this diagram here. And what we try to do is we want to obtain documents from across the organization. Now, I'm using the term documents quite loosely here. They can relate to any source of information within your organization. They can be code, they can be non-code sources of information. But ultimately, we're building up an index or a representation of these documents in what we call vector space. And the AI tooling, when the user asks a question of the model, it's going to use a retriever to perform a similarity or semantic search against that vector space to see are there any documents in there that are related to the question or the problem at hand. And if there are, it will retrieve those documents, enrich the context, and populate the context window with those documents. And the goal ultimately is that the model here is going to be provided with all the information that it could possibly need to answer the question in a suitable manner, right? And so by that we mean, it's going to provide a response that is personalized, it's going to be relevant to the problem, it's going to be acceptable to the organization, all right? Now, where do these documents come from? They can come from a variety of different sources. So the most obvious place is on the end user's workstation, right? So in there, the user has cloned, these projects, these repos locally, and in there are existing software patterns to solve common problems. So that's a great source of context. We can also use remote Git repos. So some organizations connect their repos directly to their AI tooling, and they do this for a number of different reasons. But in the context of application modernization, there might be best practices in there, and there might be, tried and trusted software patterns for solving domain-specific problems that we want to expose as code suggestions to the end user. And then finally, we have non-code sources of context as well. And for example, you might have a Confluence page or maybe a SharePoint system that describes the system that we're building for, all of the functional requirements, the non-functional requirements, or maybe you're using Jira, and in there we've got tickets that describe the change that we're working on for the target system, and describes what is expected of that change. So this is all valuable information, and we can use RAG to introduce some degree of determinism in the output of the model. And so here we're looking at a practical example of this, where the user is asking the question, and what we're looking for here is a software pattern, a tried and trusted way of solving this particular problem that is related to our organization and how we do things in our team and in our organization. What we're not looking for here is some response based on generic open source code, right? We want to see how we would solve this problem internally. And, in the bottom of the response here, you can see where Gen AI has derived this code suggestion from. So there's a lot of existing files and work in our workspace, and we can open up that file and see from where this code was derived. Okay, we can extend that as well then to remote Git repos. So here we've connected a couple of repos. These are repos that the end user may not necessarily have access to. And so the end user here, all they have access to is the actual packages from the registry on this server. And they've included these dependencies in their application, as you can see. And in the code that they're working on, they have a couple of imports from that dependency or library. And, they're working on a problem here. And because they don't have the source code, they may not necessarily know how to solve this particular problem. And so, they can ask Gen AI to provide that solution. And what it's going to do here is it's going to look at the software patterns and the solutions that it can see in these repos that are related to this particular query or problem. And in here, again, under references, we can see where this came from. And you can see these includes now remote references as well. And in this case, I do have access to the repo. So when I click on these references, it opens up the files in my browser. And so I can see where what the AI tooling used as inspiration for this particular solution. And, all that remains now is to kind of just accept that solution, introduce that into my code, as you can see here. And the last step then is to kind of just run this code. And, this is something that we'll see runs first time and provides the desired functionality, which is also acceptable to the business. That's really key. In here as well, this is now connecting to non-code sources of information. So here we have a Jira ticket where we're defining the guidelines for building microservices. So we're talking about JDK 20, Spring Boot, the Open API standard. So these are we've laid down the ground rules for how we build REST APIs and services. And so now the user is going to connect to those rules. So there's an integration here with Jira. And they're going to provide a prompt to say, hey, listen, I want a REST API that serves, a certain endpoint. And the GenAI tool is now providing a suggestion or a response that is in keeping with those guidelines and with those requirements. All right. And when it comes to an application modernization exercise, you can sometimes be faced with a lot of code, a lot of files that need to be introduced. There's a lot of moving parts here you can see. And this could ordinarily take quite a lot of time to go through all of these steps manually. But what's nice here is the assistant will perform all of these steps for me and really save me a lot of time. So, we're running these commands directly in the terminal, and it's now creating the files within the IDE. And it's, again, now running commands to install the application and now run the system. And here we go. We have a running system, and it's running on port 8080. Because if you remember in the Jira ticket, we said we wanted this to support the Open API standard. We saw in the response that there is a Swagger document that should be available in that running application. And so we can have a look at that. So what's key here is that the software that's being produced here is, again, we've introduced a degree of determinism with this generated response. And so in this Swagger document now, we're just going to interact with this new service. And for the purposes of today's discussion, we're going to pass in O'Reilly as the value, and you can see that we have some working code. So that is fabulous. All right. So that's using RAG to really provide personalized and highly relevant responses. Now, once we've generated the code, how do we ensure, that as we're going along, how can we ensure that we're provided with proactive advice? It'd be great if we had somebody that could tap us on the shoulder and say, hey, listen, I want to give you a recommendation here, or, hey, there's an anti-pattern in what you're trying to do. We want some way to receive proactive coding and architectural best practices. Now, we looked at RAG as a way of doing that, but from an organizational point of view, how do we introduce some degree of governance and control? In a lot of organizations, a common approach to that is through code review, and that's always usually a human exercise, right? The thing is, though, that our code reviewers, they're a protected species, right? They're, very often there's not enough of them, and they're time sliced across many different projects. And, they're already very busy as it is reviewing human generated code. The last thing that we want to do is bombard them with, all of this AI generated code as well, and effectively kind of DDoS our code reviewers, right? So what we want to do here is really try to lessen the burden on our code reviewers. And one way that we can do that is through AI assisted code review. And so the idea here is we're going to provide a bunch of rules that we've created to the GenAI tool, and it's going to use that then at inference time to provide code suggestions to the user in the IDE that are in keeping with our organizational standards and in keeping with those rules. And also, we want as well for the code review agent, if you want to call it that, we wanted to also use these rules to, when the user has pushed code into a feature branch or into a pull request, we wanted to use those rules to ensure that the code quality is of the required level, right? So it's going to be some level of enforcement as part of CI. Okay. Now, where do these rules come from? Well, you can feed them directly into your GenAI tooling, or you can have it pull these rules from maybe a wiki page, or if you're using a Java style guide, or even past pull request reviews, right? There might be some comments in there that would serve as really, great guidelines for future work. So this is a quick example here of this. In this case, we have a bunch of rules that have been provided directly to the AI assistant. And this is a Python example. And So, having a quick look at maybe what one of these rules looks like. Very important in this case to provide what an example of what good code looks like, and also an example of what bad looks like. So armed with these rules then, the code review agent, here what we're looking at is the user has pushed code now into this PR. We have some CI that's running. You can see that this is what's called a tab 9 PR review agent that's running. Here we're looking at the diff, so we can see what changes the user or the developer is proposing. And the review agent is going to look at these changes, and it's going to see, based on the rules that we've provided, are there any violations in there? And when there are violations, it's going to flag these to the user in the form of comments in the PR. And so you can see one here. We have a comment to say that we shouldn't use async in the signature if we're not actually doing async. And another one that's stating that all constants should be defined outside of functions. So these are pretty trivial examples, but you can use these rules to identify code quality issues, defects, things that violate your organization's best practices, security vulnerabilities, you name it. All right, now we get on to test generation. So, once we've reverse engineered the legacy system and we understand the business logic, and we've now, about to generate the code, or maybe we've even generated the code, how do we ensure that that code is going to work? All right. So obviously, the obvious answer to that question is, through tests, right? So I think I'm kind of running out of. I won't have enough time to go through all of the things that I wanted to show you around testing. So I wanted to show you how Gen AI is just excellent at generating unit tests for your code, and how you can also even take a test-driven development approach, right? So you could start with, you can start with the test. Once you understand the functionality of the legacy system, you can then write tests for the new system, and then have AI also generate the code to pass that test, right? And kind of start to iterate with the assistant. So I won't have time to show you all the test scenarios that I had planned, but I do want to show you this one. This one is where we're using behavior-driven development, and we're using Cucumber and Gherkin. So the great thing about Gen AI is, we can use it to understand the functionality and the business logic in the legacy system, and then use that understanding to generate test language. So on the right here, you can see Gherkin syntax that describes a feature that we want to test in natural language and the scenarios for that feature. And as a kind of a double whammy, we're now also asking the assistant, now that it's created that test language, we also want it now to generate the Cucumber code to execute those tests. And here it's looking for specific HTTP response codes in the code. I'll explain in a moment where that's coming from. But, I think this is really, really useful for application modernization, right? So, when we're building out the new version of this system, and we want to ensure that it's working as expected, we can use behavior-driven development as well to be sure and to satisfy ourselves that the new system is behaving in the way that we expect. All right. So here we can see we ran those tests against that endpoint, and all of the tests have passed. Now, the code that Gen AI provides to me here was very specific in nature, and I want to show you why that was. So I used what was called a custom command here, and in this custom command, just basically it's a wrapper for all of these instructions. So I'm telling Gen AI to use all of these frameworks, and I'm telling it what response codes to expect from the service that it's testing. So, again, that's another kind of lever you can pull in terms of introducing determinism in your generated code. I did want to talk about code coverage as well, and how, you you can use Gen AI to also ensure that you're meeting your code coverage thresholds. But I want to move on to the last topic here, which is reducing technical debt with AI. And, we'll go through this very quickly. So, historically, a lot of decisions will have been made with these legacy systems where you've ended up with maybe unpredictable behavior in the code, or maybe it's just been simply neglected, and there's a lot of inefficiencies and maybe vulnerabilities in the code. And so Gen AI is fantastic at helping you to reduce technical debt. And by that, I mean optimizing code, refactoring code, debugging code. So in this case here, in this example that you see on the screen, we're asking the AI system to help us find optimization opportunities in this code. And so, Gen AI is just really fantastic at that. It's a, it's a real powerful mechanism to really modernize your legacy applications. And, it's going to really help you greatly reduce technical debt in your systems. All right. And the last thing then that I wanted to cover, but I don't think I have enough time, is, generating documentation for the new system that you're building. And so, again, Gen AI, coding assistants, they're powered by LLMs. They're fabulous with text. And so, this is something that's going to save you a lot of time in your application modernization efforts. And so just a quick recap. So that's reverse engineering, code generation, best practices, generating tests of different sorts to validate the new system, reducing technical debt, leveraging the power of Gen AI, and then finally producing documentation. These are all of the things that Gen AI is going to really automate and perform for you at great speed and really help you along your, quite a long way on your application modernization journey.